Okay, so this is on chapter 4 of the Head First SQL book. And this is the first chapter that dives into database normalization. Now, this is a little bit more subjective than previous chapters. It's a lot more about empirical analysis, I guess, than straight regurgitation of commands. So, as you know, hopefully by now, SQL is all about relationships. It is a database management system. And so, relational means that we're looking for how columns relate to each other. And that's the key for all of these normal forms of databases. And so these are just the 3 big steps that you should be looking at when you make your database. You should pick the one thing you want the table to describe, make a list of the information you need to know about your one thing when you're using the table, and break down the information about your thing into pieces you can use for organizing your table. And that means essentially make it atomic, which we will look at. So atomic in SQL means that we've broken down data into the smallest units it can be without losing any efficiency, essentially. And the thing about atomic tables is that atomic is very subjective and it depends on the database's application. And so without knowing the context, you can't really judge whether a table is atomic or not. I believe the book covers this. So, taking a look at this database, which appears to be a database of a realtor, you can see he has street number, street name, property type, and price. And this looks pretty atomic. It's divided into logical units. But the one thing that we should look at is, should the street number be a separate column from the street name, and why or why not? And for a realtor, he might be selling multiple properties on the same street. So I would say that is atomic, because the realtor, or for a realtor, the street number is likely very important, because they might have houses on the same street and they might want to be able to search by street number. Now, if it were a pizza delivery person, this could be atomic. Order number obviously should be its own column. And the addresses here, we have street numbers in them, but these are very ephemeral. These will change all the time, and likely he would just be copying these into a GPS or something. And so if we chopped out these numbers, that would not make this database more efficient, and that would be making it subatomic, or chopping it into smaller pieces than are necessary. So that would not be atomic for a pizza delivery guy. But these same addresses we could chop into street numbers and street names for a realtor, and it would be atomic. And so that's where you have to be very careful. And so again, atomic does not mean divided up into every teeny little piece that you can think of. Atomic is more about logical units. What are the smallest logical units that you can put it into? And here are some rules. Here are some rules of atomic data that are a bit more quantified than what I was talking about. The first rule, and these are really, really things you should memorize. The first rule is a column with atomic data can't have several values of the same type of data in that column. And we'll look at examples of these rules. And the second rule is a table with atomic data can't have multiple columns with the same type of data. And those two rules sound very similar. They're actually pretty different, but unfortunately the wording is very similar. So this violates rule 1 because we have ingredients and then we have multiple members of ingredients here, and so that violates it. You should not have commas in an atomic data entry. And so that's what this first one means, because we have several values of ingredients. Flour is one ingredient, milk is another ingredient, egg is another ingredient, and it just keeps going. So these are not valid. Well, they're valid, but these are not atomic. And going down, this has the opposite problem. This is very divided, but you can't have student 1 as a column, student 2 as a column, and student 3 as a column, because we can say each one has a data type of student. And the rule says that you cannot have multiple columns with the same type of data. And so this is a student column, this is a student column, and this is a student column. So if it were teacher and student 1 like that, that would be atomic, but this whole table is not atomic. And these rules are not subjective. Regardless of the application, if these two rules are not followed, it's not atomic, and can't really make an argument against that. Now, the reason that the book goes so deeply into atomic tables is that now you have to learn what comprises a normal table. Now, a normal table, before we make one, you have to have a motivator for why would you want to have your table be normal. And you don't want to do the extra work to make it normal. So that's one reason you don't want to have a normal table. But you do want to have a normal table because they will not have duplicate data. And so obviously less data is less size, is less strain. And so you have less to search through. And the end game is how fast can you access this data in most applications. And so your queries will be faster. And she's thinking to herself, why should I care about normalizing tables? And I guess they told her because even when your tables are tiny, that adds up. And also, most apps are hoping to grow. And so maybe with your 10 little test entries, it doesn't matter, but when you get 1,000 users, it'll start to matter. And eventually, when you get millions, if you have like a really successful app, although you probably scale up from SQL at that point, but once you get a ton of users, that does make a big difference, and that can actually make a big difference in user retention. And having low user retention is how a lot of companies failed, like how Foursquare actually failed to enter the social media market. Foursquare was actually a very promising platform. They wanted to compete with Facebook, well, actually primarily with MySpace, and Facebook was also entering the arena. And Foursquare had a good platform. It had some very good developers, but they could not optimize their loading times, and it was down so frequently that people just stopped using it. And it likely you'd be using Foursquare instead of Facebook if they had done things similar to normalizing their tables. So they're saying atomic tables take you halfway to what's called the first normal form. And for a first normal form, every row has to be atomic. And hopefully that's pretty much down what atomic means. The other rule is that each row has to have a unique identifier, which is known as a primary key. So, what is a primary key? A primary key is a column in your table that makes each record unique. Now, a primary key could be something that has external meaning. In this very not secure example, it's social security number, because the idea, although this actually isn't always true, unfortunately, but the idea is that social security numbers are assigned uniquely to a specific person, so that would be a primary key, because the main thing is that primary keys have to be unique. And so you can make it that, you could make it some arbitrary index. There are a lot of different primary keys that you can make, but they have to be good, unique keys. And please, if you make a database, do not use a social security number as your primary key, because that's not a good idea. A primary key obviously cannot be null, and these are rules that you probably should write down. They're very important and they're very basic. A primary key has to have a value. It shouldn't be all over the place, and they are immutable. You should not change primary key values in any circumstance, because that would cause kind of a cascade effect, and they should never be changed. And like it's saying here, the best way to do it is to make something that is not externally useful. And so, in case you have the unfortunate occurrence of having somebody use SQL injection and dump your whole database, you hopefully you will have encrypted the more important information, but you can't really encrypt a primary key because that's how it's indexed. So the primary key is typically in clear text, and so the best practice is to make it something like this, just 1, 2, 3, 4, 5, and you can go into the millions, but it'll be a sequence. Every row will have a unique value, and that should work out fine. And again, these are good things to type out on your own. This is just a copy-paste of something in an earlier chapter where it's a table, but it does not have an index. It does not have a primary key. So what if you want to make this table one more time, but you want it to have a primary key? You can use this handy little command here. It's show create table, and then a table name. And this will, with some stuff added to it and with slight modifications, it will output a command that will recreate your table. So using the show create table command, you get this out, and you could copy paste this and you could make your table once again. And yeah, one important thing is that it makes these backticks instead of single quotes, and that's okay. You can still use those. It's just a different thing. So if you want to make a primary key, primary key should be the leftmost column in a table. And so if you wanted to make one, it has to have a name, and in this case contact ID sounds fine. Make sure it's not null. That's very important. That keyword, not null, you have to say that. And probably it should be an integer. I guess you could make one that's not an integer, but it seems easier and less painful to make it an integer. So contact ID int not null, and then on the very bottom we say primary key, and these are new keywords, primary key parentheses And remember, it seems odd, but you do have to have parentheses around the primary key. Contact ID. So this is explicitly telling SQL, I want this to be my primary key. And this will actually be very, very important. So it might seem like you can just enter in this and be done, but you really need this last statement, this primary key contact ID. Now, one other keyword, and I know it probably seems like you're being inundated with a ton of keywords, but it's something where you'll get the hang of which ones you need to know and which ones you don't, and you'll learn them with practice as well. So, saying auto increment will make your life much easier. This ensures that the primary key is truly unique, because each time you add in new data, it'll throw on your primary key there, and it'll make it one more than it was before. And so if you have one entry and you have 0 as your primary key for that, and you toss in another entry, the primary key will automatically be made 1. And that is the magic of auto increment. And I know it seems kind of odd. Not null has just a space between not and null, and auto increment uses an underscore between auto and increment. So you just have to remember that, but tack that onto the end of your primary key declaration right here. And hoping they have an example of this down here, because that would be very helpful. So here's their little sketch of a table. You can see it increments, increments, increments. You can overwrite it, but that would make it not normal, because remember, one of the requirements for a primary key is that you don't change it. So we went over the method using show create, and it outputs the code that you would use to make that table again. But what if you want to add your primary key to an existing table? I'm not sure if I can rotate this. Let's see what happens. There we go. Crap. How do I? There we go. Okay. So this is what that command looks like. We have a new command called alter, and we say alter table. We have our table name, and we have to add a column in because it's a primary key and it needs to have its own column. So we have add column, contact ID, int, not null, auto increment, and as you recall, these are all things that we just talked about, except for add column. That's a new one. And after that, we tack on yet another keyword. And I'm sorry, SQL likes to do this. It's like German. They like to tack on a ton of words. You say first, and that means leftmost. So it's saying add column, but add this column all the way at the beginning. And as I had said before, it's imperative that you make your primary key column the leftmost column, and that's what this does. Now you can also use second, third, fourth, fifth, etc. You can say last, so you can add a column into any position like this. And then I know this syntax seems weird, comma, add primary key, and this is what we did in this last example, and then the name of that column that you just added. And again, everything in SQL ends with the semicolon. It can seem illogical because many command-based languages don't, but just remember you need that semicolon. And if you're using a prompt, it may give you something like a dash instead of an equal sign. I know that's what PostgreSQL uses. If you've entered in everything but that semicolon. So that's very important to remember. And oh, here, should rotate this one back here. Okay. So, believe they want to go more. Oh, okay, that's it for this chapter. And probably the most important thing to know from this chapter is a table first normal form or is it not? And to know that, you have to know, is it atomic or not? And remember, part of determining whether it's atomic is subjective, and part of it is whether it follows those two rules. So you have to look at, is it logical in this context? And then you have to look at the two main atomic rules, which are, does it have sort of like a list of the same data types, and does it have multiple columns that show the same data type? And it might seem illogical that you can't have multiple categories, because like what if you wanted to have a table of movies where movies can have multiple genres and you needed to represent that? And the answer is you can, and you can make it in normal form, but it requires a little bit more sort of database engineering that we will get into later. And from that, you just have to know that first normal form has to be atomic, and it has to use a primary key. So there isn't too much to it as long as you understand sort of the baseline facts under it. And again, most important part of primary key is that it is unique and that you have to use auto increment unless you want the same primary key every one, in which case that would not be first normal form because the primary key is not unique in that case.